Hey grade 9s! So over the last 2 years you've been playing around with the Cartesian plane a little bit. Your teacher would have taught you how to plot XY coordinate pairs already, and this was preparing you for a section that we call functions. Now, functions are going to become incredibly important in maths from now on. Over the next few years they're going to count a really big chunk of your maths mark, and they're going to make an appearance in science too. You're going to hear people in the higher grades that talk about functions and really complain about them and say they're so difficult. I don't want you to listen to them, okay? Functions are not one of those sections that you need to kind of go into the test hoping that you get it right. There aren't that many trick questions in functions. This means that you can prepare for the kinds of questions you're going to get asked, and if you can do it before the test, you can do it in the test, okay? And I'm going to show you just about everything you need to know. In this video, we're going to get started with me showing you how functions can be used in the real world, just so that you can understand them a little bit better and understand why we're doing them. Then I'm going to show you briefly what kind of functions you're going to do all the way up to metric, just so that you know what's coming and you're prepared. And then lastly, I'm just going to show you what you need to go back to grade 8 to quickly and just brush up and revise quickly, because there's a section of work there that you really need to know well so that you can do well on functions and your functions don't suffer. Okay, let's get going. What are functions? In a nutshell, functions are just a way of relating one variable to another. So before you think that sounds complicated, let me show you some examples. We're just going to have some fun here, okay? So there's a farmer and he's farming with bunnies, okay? So he's experimenting. He wants to see how fast the bunnies pick up weight when they eat a certain amount of carrots every day, okay? So he divides them up into, say, 4 groups, A, B, C, and D, okay? And he decides that group A, he's going to feed 2 carrots. Group B is going to get 4 carrots every day. Group C is going to get 6, and Group D is going to get 8 carrots every day. And then he weighs them at the end of the month and he tries to see how much weight have they gained. So group A has picked up 1 kilogram, group B has picked up 2, group C has picked up 3, and that group has picked up 4. Okay, so essentially what we have here is a function. Okay, I'll show you now. So we can plot that on the Cartesian plane. So let's quickly plot these points. So when he gave them 2 carrots, they picked up 1 kg. Okay. When he gave them 4 carrots, they picked up 2. When he gave them 6 carrots, they picked up 3. When he gave them 8 carrots, they picked up 4. Okay, and there you can see you've got a straight line forming. Okay, I'm not drawing very nicely, but there you go. That's the idea. Okay, so you can clearly see this is a straight line function, and the usefulness of this is the farmer can actually go and you can ask a question without actually doing an experiment. He can guess. Now you can't really ever with real life predict 100%, but he can do what we call extrapolate, because I mean really if you think about it, this line stopped here, right? But he can extrapolate this line. And he can say, I'm going to guess that the line's just going to continue as it was continuing. So I can read off a value. I can say I'm feeding the bunnies 14 carrots a day. Then, okay, this is going to go back to 7. Okay, there's a relationship here. They're going to pick up 7 kgs in a month if I feed them 14 carrots. So you can ask any question. You can ask, how many carrots do I need to feed to make them pick up 6? And then you can read it back that way, see? Okay. So that is how straight lines kind of work in the real life, and there's many scenarios where they can be used. Let's quickly take a look at another example. Let's say there's a plague going around, okay? I call it the tickle bug plague, okay? I've just made this up. I don't think there are really things like tickle bugs, but in my imagination, okay, here we are making up tickle bugs. Tickle bugs are really a pest because every time they touch you, they tickle you, okay? So So there's a pandemic of these bugs. So everyone in your city hears about these bugs, and they're closing their windows, and they're closing the cracks under the doors and sealing everything. You clean your shoes before you enter every day, because nobody wants bugs that are tickling you all the time. So, but one day you've got 2 bugs that enter your house through a keyhole, and you don't realize it. So we start with 2 tickle bugs. But every day, these tickle bugs, their population size doubles. So day 1, day 0, you've got 2 tickle bugs. Day 1, you will have 4. Day 2, you will have 8. Do you see the problem here? Day 3, you will have 16. You might not even have noticed your house has tickle bugs yet. But by day 4, you might start noticing some crawling around. I'm thinking by day 5, you will definitely notice that you have a tickle bug infestation. And so on and so forth, okay? If you don't do something, that thing is just going to keep climbing. So I've labeled my axes. Let's quickly plot this onto the graph. On day 0, we have 2 tickle bugs. I'm just kind of going to guess where that's going to be, because my axes need to accommodate quite a lot of data here. Day 1, it's going to be 4. Day 2, it's going to be 8. Day 3 is going to be 16, still very little. Okay. Day 4 is going to be 32. Now it's starting to climb a little bit. Day 5, and then day 6, all of a sudden it starts taking off. And now if this had to go on, day 7 we know would be 256. So day 7, that's a day it will really start going completely crazy. That'll be like way up here. Okay, so this is what we call an exponential graph. You'll see them in life a lot in population cycles. So populations, when they're left unchecked, they tend to multiply like that. This is why governments freak out when they hear about a new disease or something, like a cholera outbreak or something, because they know if it gets to this place of year, it's just going crazy in the population. There's no stopping it anymore. So the closer you can get to the first people that have it and trying to prevent spread, the better, because then it's just never going to get out of hand. But once it gets to that really exponential part where it just shoots up, it's really hard to control. I don't want you to worry about this though. You're only doing exponential graphs next year in grade 10. I want to do one more example with you. So I want you to imagine that you've started your own business, okay? You've decided that you're going to make and sell the coolest soccer balls ever for boys and for girls. I don't know if you're designing glow-in-the-dark soccer balls that you can play during load shedding when there are no street lights or whatever. That would be pretty cool. So you need to decide on the price of the soccer ball that you're going to sell. I'm not going to use actual hard numbers for this. We are just going to kind of map this out as we think it's going to work, okay? So you kind of have a sense of price. So these balls cost 50 Rand to make. That's your cost price, okay? This is your price per ball, and this is your profit on all the balls you've sold. Now, if you're not sure where to sell your balls, that's a problem, because if you sell the soccer ball for too little, then you're not going to be making a lot of profit. And, maybe if you're selling it for 60 Rand, maybe people would have been willing to buy it for 80 Rand. It would have just not bothered them, But maybe if you're going to ask 300 Rand for a ball, it's going to be too much. You hear what I'm saying? So we've got to figure this out. So you decide you're going to test this. For 1 month, you sell your soccer balls for 60 Rand. And you kind of make a little bit of profit, but not a lot, because, hey, let's face it, selling at 60 Rand, you're only making 10 Rand on each ball. So, not a lot of money you're making, okay? So then the next month you decide, no, wait, people actually like these balls a lot, we're going to push the price up. And guess what? You don't lose that many customers, and you're making more money because you've got a bigger profit margin. The next month you push it up to 80 and you're making even more money. The next month you push it up to 90. Your profit margin is getting bigger. Maybe you're losing a handful of customers, but most people are just still happy to pay that price. And then 100, and you're just keeping on growing. And then by 110, something weird happens. You start noticing that it's like kind of like it's flattening off. It's not getting that much more. And then by 120 you can see, whoa, something's going on. Because now our profit is dipping. Our profit has dipped a slight little bit, and you think maybe this is the tipping point. That was the tipping point where people are like, not sure I really want the ball at this price. 120, too many people are going no. So even though you're making like $70 off each ball, the problem is some of your customers are starting to walk away and go, the price is too high. You just want to be sure, so you push it up to 130 the next month, and there it starts dipping. And now if you're really not a great businessman and don't catch the hints, you're going to keep on raising the price, and your profit would keep on going down because it's just getting too expensive. Okay, so this shape that we have here is a very famous shape in mathematics and statistics, and it's called a parabola. And well, you can see now how this is useful for business. This is incredibly useful because now you can see, ooh, my maximum profit is sitting right there just before 110. I need to maybe price this at 109 Rand or 108. That's where I can get maximum profit on each ball, and people aren't too scared off by the price. Okay, now real life is a lot more complex than these examples, but you can actually see how they are a very real part of your life. Let me quickly show you the different functions you're going to be seeing until grade 12, okay? So in grade 9, we are doing straight lines. Grade 10 is a crazy year for functions. In grade 10, you are going to be doing parabolas, hyperbolas, not to be confused with parabolas, okay? A lot of us get confused with this. I spent half of my school career trying to figure out the difference between them. And then lastly, you've got the exponential graphs. And in grade 10, you'll also be doing something we call trig functions. Don't break your head about it now. It's not as bad as it looks. In grade 11, you will not be doing so many new functions. What you are going to be doing is a lot of transformations. So the questions will get a little bit more difficult. And then lastly, in grade 12. Grade 12 is a bit of a mixed bag, but if I have to highlight something, it would be the cubic functions you're going to do. A little bit like parabolas in that they have a turning point over there, see? Except cubic functions have 2 turning points. I love cubic functions. They're so much fun. And that's actually part of calculus. But don't be scared by it, okay? I don't want you to get a fright with everything I've just showed you, okay? I just did it to show you where you're going so that you can find your feet. For grade 9, you are only going to be doing straight lines. And if you go through all my videos in order in my playlist and you make sure that you study hard and practice lots, you're going to just sail through the section with flying colors. There's one last thing I want to talk to you about. You need to make sure your equations are up to scratch. Now, when I say up to scratch, I mean you should be really, 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 really good at doing equations. Why do I emphasize this so much? So remember last year you did equations in grade 8? And you do that in grade 8 because equations are the foundation of all high school maths. They're going to pop up everywhere. And if you're going to struggle with equations, your functions are going to suffer and all the other sections. So I want you to go and sit down and just revise that section. And if you're feeling it's a little bit bumpy or a little bit scratchy, go to your teacher, go to a tutor, get somebody from a higher grade, find somebody to help you with those equations so that you can just do them well and they're sorted out and easy, okay? Thank you so much for watching, and I hope that this video helped you. If it did, please subscribe to my channel so that you can find more videos like this one easily.